Fiber optic systems have replaced the copper transmission systems of the past. Working with optical fibers and optical connectors is much more critical than their copper counterparts. Throughout the installation, splicing and connectorizing of optical fiber and the need for cleanliness is the single most important issue facing the fiber craftsperson. With today's reliance on gigabit rate transmission and the evolution to DWDM networks, cleanliness becomes even more important in the operation of these high-performance fiber systems. Before we can clean optical connectors effectively, we must first understand how connectors get contaminated in the first place. By far, the most common source of contamination plaguing connectors is in the form of airborne particles. The air is full of dust, pollen, smoke, water, and chemical vapors, as well as microscopic oil droplets from numerous industrial and biological sources. This contamination covers everything in the environment near the fiber system equipment. Humans and their clothing are efficient carriers of contamination. Thus, it is very simple for contamination to be transferred to connectors from surrounding surfaces, general handling, as well as the air itself. There are three types of environment where fiber optic connectors will be found. In laboratory settings, you will usually find some type of controlled atmosphere to reduce contamination. This may be as simple as a closed room with hard, clean surfaces and limited access. In some cases, the room may be hermetically sealed with a pressurized environment. High-performance filtration systems remove all particulate matter, provide precise temperature and humidity levels, and workers must wear special protective clothing to avoid contaminating the work environment. The amount of contamination found on connectors in lab environments is considerably less than in other areas, but cleaning procedures are still required. In the manufacturing environment, surroundings will have much more contamination than in labs, and cleaning becomes more important. Manufacturers have become keenly aware of the role that contamination plays in the quality of their products and strive to keep the work areas as clean as possible. Workers ensure that connectors are thoroughly cleaned during assembly operations. Specialized equipment is now available to provide consistent, high-quality results when cleaning fibers and connectors prior to termination. Automated equipment makes manufacturing processes easier. Here, a new product shown at the Optical Fiber Conference features a polisher, inspection scope, and return loss meter integrated into a convenient production instrument. It is in the user environment, however, that the most serious problems with contamination occur. Fiber optic systems are often located in dirty locations such as entrance facilities, janitor's closets, boiler rooms, and basements. In these places, it is very easy for contamination to work its way into precision optical connectors, degrading system performance. Thus, it is the user environment that must be given the most attention in connector cleaning. In the past, lower speed, lower power systems were able to tolerate moderate amounts of contamination. Since the early 1980s, connector designs have featured physical contact of ferrules to obtain the lowest attenuation and reflection levels. The role of connector cleaning was primarily to remove large particulate matter to prevent surface damage during mating and improve physical alignment of the connector components. Alcohol-soaked pads were the cleaner of choice, while some technicians inappropriately wiped the connectors on their shirts. Bad cleaning habits evolved over time due to a fundamental unawareness of the importance of proper cleaning. Average airborne dust particles are on the order of 2 microns in size, while average smoke particles can range from 3 to 5 microns. A number of these particles could settle on the 62.5 micron core area of a multi-mode connector before a performance reduction would be noticed. However, single-mode fiber cores are only about 9 microns in diameter. In this case, even one dust particle can block more than 10% of the transmission area. When connectors are mated repeatedly, normal wear can shave tiny flakes of metal from the internal alignment sleeve, as well as very fine ceramic dust from ferrules. This material may accumulate and contaminate the connector. Another point to consider is that every time a connector is pulled from its mating sleeve, a vacuum is formed within the sleeve that sucks in contaminants that may be floating in the air nearby, so the more you mate the connection, the dirtier it gets. Oil vapors can adhere to internal parts of the connector, attracting and holding airborne particles. As the grime accumulates, it forms an abrasive that can scratch the precision optical surfaces of connector ferrules during mating. This is particularly true of high-performance PC-style connectors. Even the tiniest scratches on DWDM connectors can result in severe performance degradation. Once the connector is damaged, no amount of cleaning will restore it. Replacement or repolishing is the only option. Oily residues can also cause high reflectivity at connectors, which can show up as increased bit error rates in high-speed systems. DWDM systems are extremely sensitive to even minute amounts of contamination. What is worse is contamination, such as oil residues, may affect some wavelengths more than others, so the technician may suspect a problem in individual transmit-or-receive circuits when the real culprit is a dirty connector. In order to keep connectors clean and undamaged, it is very important to observe correct handling procedures. Pay particular attention to alignment while mating connectors to avoid dragging the optical surface along the inside wall of the coupling sleeve. Hold the connector so that the ferrule passes straight through the center of the sleeve.